Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome in lecture 31. Uh, Basically in this lecture I will choose another example from the same book, that is R.C. Habler, and in this book basically uh, there are so many examples related to a frame structure. Okay, now in the previous lecture I will explain that how you can model this example in your structure analysis program, and these are the results. Okay, you can check the results. uh, you do your homework on it and check the results with. Okay, and this is the bending movement diagram. Clear? So I hope you will do the practice, and this is the result. Okay, you can compare your bending movement diagram with this. Okay, I am choosing another example. Okay, I'll leave these examples because there you can see whenever you are solving the frame structure, so you must need to look EI values. Okay, if EI constant, so you can solve those example. Okay, if EI is varying, then you need to define your properties. Okay, and that is a lengthy process. I don't want to confuse you people at this moment. Okay, I want to solve you those problems which it is at this level you can solve it. In my coming lecture inshallah I will solve these problems. Okay, so please watch the videos, the lectures. I will do these problems as in my coming lectures as well, because you can see the moment of inertia of this beam is different, and the moment of inertia of this beam, this column is different. So for that purpose, you need to change the properties of this section. You have to draw you have to first of all define. Okay, define the properties of your section. Okay, that is your frame section, and here you will modify, here you will change the moment of inertia. The moment of inertia, these are the section properties, and here you will change the moment of inertia about different axes which is given. Okay, so this is a lengthy process. I don't want to confuse you people at this moment. You just need the simple problems, that how we solve and how we get the exact answers. So therefore I am leaving these kind of examples. Clear? So this example I will already done. Okay, you just need to check the shear force and bending moment diagram. Okay, this is the same example I'm leaving because here moment of inertia are changing. Clear? So there is also changing. Okay, this is the example which I attempt here. Okay, you can say this is a one bay, one story frame. There is one bay and one story, and there is a UDL. So D and C are fixed. Okay, and A and B are hinge support. Clear? So let's see, we will do it. Okay, and we just draw the shear force and bending moment diagram. Okay, so there is no shear force and bending moment diagram, there are just only reactions, these reactions. Clear? So let's try. Okay, the units are kf per feet, and this is a kind of wind loading. Okay, on a frame. So let's see. The unit should be kf feet. Okay, new template, and kf feet. This one, we have one story. We have story height equals to 12 feet and 15 feet. This is 12 feet. Okay, story height is okay. We have only one bay, and the bay width is basically 15 feet. Clear? And okay. Clear? Delete this one, and you have ABR pin support. So we have ABR pin supports. Select this one, assign frame load, distribute it, make sure this is 0. Okay, modify it. Okay, make sure units is in kef feet. You will be in global axis. You should select X, and here you can see that the load is in positive X direction. Okay, in positive X direction, so therefore we don't need to insert a negative value. Clear? And the load is 1.5 feet. Clear? You can select this option, you can select this option. Clear? Because we don't assign any loading. Okay, so this is the first loading to this member, so this option will work. Okay, you can select this one. Okay, load is assigned, and you just run the analysis. Save it. This is example number 37. Clear? Okay, so this is the shift bending moment or shear force diagram. We need reactions, so let's check the reaction. Clear? The reaction 7.2, 13. Okay, 13, 7.2 and 7.2. Clear? So the reactions are okay. If you want to see the shear force diagram, you can select this option. If you want to see the bending moment diagram, you can check this one. Clear? And these are the bending moment and shear force diagram. The maximum bending is there. Okay, and at this point. Okay, so this is the example. Okay, that how we can analyze a frame for a wind loading. This is also simple. Okay, this is a two-story. Okay, how you can assign it, I will just give you some hints, okay, about this example. So in this example, basically you see that the number of grids, okay, in X direction, if you are using your grid spacing, so this is X1 and this is X2. So in X direction you have two axes, and in Y direction basically, in Z direction you have 1, you have 2, and you have 3. Clear? So in Z direction you have 3 grids. Clear? The spacing between grids in X direction, this one that is 20 feet. Okay, this is your bay width. Okay, if you are using your 2D frame template, so you have one bay and its width is basically 20 feet, and you have two story. Okay, the one story is this one and the other story is this one. Then you need to edit that grid spacing, and you have to insert the first story height, that is 15 minus 10, that is 5 feet, and your second story height will be 10 feet. Clear? Your second story height will be 10 feet. And if you are using your grid spacing, so just press the edit custom grid lines, and your AB spacing is 20 feet, so this will be okay. But in Z option, basically, if you select, for example, if you select this grid only, so in this basically you have, in grid you have 2, make it 1. In Z direction there is 3, In x direction you have 20 feet. In y direction, assume it is 1, say 1, and in y direction just insert any value, okay, because you have to edit the spacing. Clear? And then okay, so you need to then edit the spacing, okay, edit grids, and there you can insert, you have only AB and delete it, okay, you have only AB, select the spacing, and AB is 20, and then you have two heights, okay, Z1, Z2, Z3, and delete it. Clear? Select Z1 and Z2 5, and Z2 and Z3 10, and Z3 equals to 10, and Z3 equals to 0. The job will be done, okay. So this is the way that how you can model your frame. If you are selecting your, for example, if you are selecting this 2D frame template, so here the number of story is 1, the story height you can put any value, or you can leave this value, okay. The number of bays is 1 and bay width is 20 feet. Now you need to use this option because your story height is different. Edit grid, and there you can adjust your spacing. Your AB is 20, okay, and delete this one, okay, delete this one and make it 0. Clear? From Z1 to Z2 you have 5, from Z2 to Z3 you have 10, and Z3 equals to 0. So through this way you can make a practice, you can do the same example. Clear? And you will practice, okay. If you have any question, okay, you can share with me. The another frame, and these are the results. Clear? These are the results, you can check it and do the practice, okay. Let's say we will do this example. Clear? So this example is basically, it is also a simple example. We have A and B are pin supports, or you can say hinge supports. D and C are fixed, and there is a anti-clockwise movement and there is a clockwise movement. So the beam is symmetrical, about loading. So let's do it. Clear? Let us do it. Kilonewton meter are the units. Okay, so convert the units to kilonewton meter. Clear? New template. Don't save it. Let's say we select this one. We have number of story equals to 1. Number of story height, I think so it is 4 meter. This height is 4 meter. So say this is 4 meter. We have number of bay equals to 1, and the bay width is basically equals to 3 meter. Clear? We don't need to edit. So this is the frame. Okay, we have hinge here. We just need to apply a moment there. Okay, so you can see that the moment is applied in anti-clockwise direction. Clear? In anti-clockwise direction. So if you draw your axis, okay, so the moment is applied about y-axis. Moment is applied about y-axis. Clear? But this is in anti-clockwise direction, so we must need to insert, and you see that I select a joint, so I have to assign a joint load. Clear? So joint load, force, here you make it 0, okay, modify, okay, and make sure units are kilonewton meter, okay, and now you need to apply the load. Now the load is applied, that is a moment, and a moment is applied about your y-axis. So you need to select this option. That is not a force, okay, that is a moment. But the moment should be applied with a negative direction because the load is anti-clockwise. Okay, the movement is assigned. If you want to see it, this one. So this is the sign of anti-clockwise direction. If it is in this direction, okay, from right to left, then it will be a positive, or you can say clockwise movement. So I select this joint now, and there I have assigned a joint movement. The joint movement at this time, this is 20. Okay, just only 20, because it is clockwise, and you can use this option as well as you can use this option. Okay, so okay, that is, so that direction is basically showing the positive direction, or you can say clockwise movement, and this one is basically the sign of negative movement, or you can say anti-clockwise movement. So the job is done. Okay, and we need to analyze now. Model do not run. Okay, run now. Save it. This is example number 38. Clear? We want to see the joint reactions. These are the joint reactions. You see, the vertical movement do not cause any kind of vertical loading. Okay, they are causing horizontal, and as I already mentioned you, the beam is symmetrical about loading, so therefore reactions are equal. So let us check the results. Okay, 2.65, 0 and 0. Clear? So this is the way that how we can analyze this frame. Okay, if you are interested in shear force and movement diagram, you select this option and then OK. If you are interested in a movement diagram, select this option and OK. This is the movement diagram. The maximum movement is applied at this point, these points. So you see movement is 0, and this is a hinge. So hinge do not take any movement, so therefore it is 0. Clear? This example is also easy. Okay, you have one bay and the bay width is 5 meters, and the story height is, you have one story and the story height is 4 meters. Clear? And you have uniformly varying load. So select this beam, and at 0 you need to select this. Go to assign menu, frame loading, select distributed loading, and once you select distributed loading, make sure self weight multiply be 0, and just you will use the spacing option. Okay, absolute spacing option, and you insert a 0 and distance, and in load you will insert this value. Okay, then at a distance of 5 meter, and another column you insert distance equals to 5 meter and load value will be equals to 0, and then in column 3 basically leave it. Okay, you don't need to use the column 3, and just click OK. So you will see your load will be assigned, and then just you need to run the analysis. So these are the reactions. You can confirm your reactions there from there. Okay, so there is no bending moment and shear force diagram, I think so. Okay, so you can draw your shear force and bending moment diagram. So I think this is enough. Okay, and I am now selecting some kind of different frames. So please share your comments, suggestions if you have any question. Okay, and watch the video and enjoy. Thank you.